Hi, and welcome to this section of the Chemistry Tutor. In this section, we're going to do some problems directly related to what we had just learned in the previous section in the atomic theory of matter. So if you haven't watched that section, go ahead and watch it right now and then come back and work these problems here, because what we're going to do is work these problems using those laws that we just learned in the previous section. So we learned about several things in the previous section. Some of the most important things that you'll understand and need to know in chemistry are the law of conservation of mass, which we talked about extensively in the last section, the law of definite proportions, which we talked about extensively in the last section. The law of conservation of mass, big picture, just means when you have a chemical reaction, the mass, the total mass of everything you start with must equal the total mass of everything you have after the reaction is done. And that's because none of this matter is created or destroyed. It's just the atoms have rearranged themselves into different components. So when we add up the mass on the left and the right hand side of the reaction, or before and after, same difference, it means that the total mass is the same in both cases. That's crucial. You'll be using that in lots and lots of problems. Law of definite proportions we talked about, that's also another really important guy. And what it basically means is if you have a chemical compound, like H2O for instance, it basically says that the atoms that make up that molecule or that compound, they join in very specific ratios. And so that guy specifically says that if you take a look at the mass ratio of the different elements present, the mass, for instance, the mass of oxygen compared to the mass of hydrogen in a water molecule, right? And you compare that to different molecules from all around the room or all different water molecules all around the world. If it's water, then it's going to have the same exact mass ratio. In other words, the same ratio of the elements are combining over and over again, H2O. It's something you kind of already know before joining into chemistry, but we're going to use it a lot because it turns out that if you just know that simple fact, you can do quite a bit of calculations and really understand what's going on chemically just by knowing those two things. And so that's what we're going to do in this section. We're going to work a few problems to flex our muscles a little bit, make sure we really understand what we're doing. So the first problem goes as follows. If you heat 1 gram of zinc and 0.2 grams of sulfur in a closed container, and then after the reaction proceeds, you capture 0.608 grams of zinc sulfide and 0.592 grams of unreacted zinc. Is this possible? So if you notice, this is going to happen a lot in chemistry. It's never going to tell you, use the law of conservation of mass to figure out if this is possible. It's never going to tell you, use the law of definite proportions to figure out if this is possible. Notice it doesn't tell you any law to use, and that's because these laws of chemistry that we've learned are so fundamental that you're expected to know them and apply them to every problem because they obey, it's like a universal thing. These are always going to be true. So what we need to do is really read this problem and avoid the temptation to just start adding numbers together, and we really need to understand what's happening so that we'll know what to do. So let's read it one more time. We have 1 gram of zinc, and we heat it with 0.2 grams of sulfur in a closed container. So we have a closed vessel, nothing can get in, nothing can get out. We heat the zinc and the sulfur in the container, we let the reaction proceed. So there's some kind of chemical reaction, zinc and sulfur coming together, right? After it's done, we open the container up and we look and we see that we have 0.608 grams of zinc sulfide, and zinc sulfide is a chemical compound when we join zinc and sulfur together. And we